Thank you very much. Welcome everybody. Great to see such a great crowd here. I'm Jaap Bresser. I'll be talking about testing with confidence. Quickly a bit about myself. I've been a software developer professionally for nearly 20 years. Worked in HR, in the healthcare sector, in startups, more established companies. Currently I am an independent software developer. I've worked in various languages, C#, Java, of course some JavaScript, some TypeScript. My first Python experience was actually Jython. Who here has heard of Jython? Oh, that's more than I expected. It's a Python implementation for the Java virtual machine. I looked it up and this seems to still be maintained but stuck on Python 2.7, so that's a bit of a pity. But that was my start with Python, and over the years I've mainly used the classic good old CPython for various things. Throughout the years, in various projects, in nearly every project I've done, testing played a role. And in a few projects where testing didn't play a role, its absence certainly did play a role, and not in a good way, as you can imagine. So with that experience, and maybe with the gray in my beard after some years, I hope to use this to give you some insights in what I found to be useful patterns I've learned over the years. So, why do we test? One of the main aims I have with testing is that it allows you to move fast while not breaking things. While certain people might think that it's cool to break things, I prefer not to. And in my experience, customers also prefer not to, and developers prefer not to, and they get stressed by customers who prefer not to. So it's better to not break things in my experience. But the easiest way to accomplish this is, of course, the easiest way, but a way to accomplish this is to check everything 3 times before you ship any code. But this is, of course, very inefficient. You want to be able to move at a reasonably quick pace. And therefore, automated testing can provide you with some confidence you need to move at that pace. Another benefit is if you do any agentic coding or AI coding, that generally works better when you have concrete validation, which you can do, which testing also can provide for you. So even in the new AI age, it's still quite useful. So I'll hope that I can impart the importance of testing and on how to do it with you in this talk. Okay, let's get into it. Basically, testing is very, very easy. When you have a function like this, multiply, you can test it like this, and your job is basically done. In practice, though, I guess most of you have experienced that there are some difficulties which you run into. And in order to help guide you through some of those challenges, I will be using an example app in which I'll look into some common challenges with testing and provide some strategies to overcome them. The first one I will be using, it's just a basic Fast API web app. I think most people are familiar with Fast API as it's a really popular framework right now. The first thing I use for demonstration purposes is email, sending emails as an example of how to deal with external services. Then I'll be looking at endpoint auth. Here we'll be looking into how to dealing with the database and the unit test versus integration test split, when to use what and what the advantages and disadvantages are. I'll be using PyTest for testing, and I'll be also using some other libraries to aid the testing. But this is not a talk of comparisons of testing libraries. So if you have something you prefer, feel free to use it. These are some libraries I have used and have good experiences with, but there are plenty of alternatives which provide also perfectly fine solutions. So let's dive into the code. Let's start with email. This is basically a simple example where we use Amazon SaaS, but you can also use either an HTTP client directly or another external email provider. The point is you basically get a global object which has one method, usually send email, which we can use in the following way. We send, it's a bit small, but we basically call the send email method with the correct arguments in order to send a welcome message. This should be fairly straightforward. But before we go about testing this, let's make some simple observations about email in itself. First of all, we just seen it's a really quite simple API. It basically had one method, send email. And therefore, it's quite loosely coupled to the app. You can easily switch out your email provider for a different email provider or an SMTP versus an HTTP service, which provides the same functionality out of the box because the API is just send email. But email is inherently unreliable. Even if your email server is 100% reliable, emails may bounce because people don't pay their bills, or email might be swallowed by spam filters. So you can't rely on email being delivered. Therefore, your application should already have some mitigations in place to mitigate this. For example, you might have a resend link after 60 seconds if a mail isn't received by a user, and monitoring of bounced emails and complaints, and if your server is up, is also a good way to get some confidence in that your email is working reasonably well. Testing, on the other hand, doesn't really add that much because you can test that email is sent, but if an email is sent now to a user, if you run the same test again in 5 minutes, it might not. It might end up in the spam filter. The subscription might have been, of the user might have been cancelled in the meanwhile. So testing doesn't provide any reasonable confidence. That is why mocking is a good solution when dealing with such services. Mocking basically means that you create a fake implementation of the email object, which doesn't send any actual email, but just registers that the method is called. So what would this look like in practice? We have the send email method. Who here is familiar with dependency injection? Quick hands up. So dependency injection basically means that the framework, in this case, both Fast API and PyTest use dependency injection, creates the arguments for the method if they invoke the method. And how they do this depends on the framework. But in the case of PyTest, you do this with the pytest.fixture decorator. So this means that we can inject the mail client into our tests. What does this do? This replaces the global mail client object by a mock, and then we yield this mock, which means that it is returned to the calling method in the test. So if we want to use this, we get something like this, where you can see that we inject the mail client, and then we just basically call the send email method. After that is done, we can use this injected mail client object and check that the send email function has been called exactly once and with the correct arguments. This way we can ensure that our app calls the email functionality correctly, but we don't test anything beyond that, not if the email is actually sent or something like that. It's actually a good idea to make sure that you don't have any credentials or ways to send mail from your tests, because you might end up with some very unhappy developers, or even worse, unhappy customers. If every test run sends a whole bunch of emails saying welcome, 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 it's maybe not appreciated by everyone. So mocking is really the way here. Let's look at the endpoint auth. This is somewhat different. Let's first look at the code. We have basically two endpoints, a users/me endpoint and documents endpoint. the most interesting part about the users.me endpoint is that we inject the getCurrentUser method, which gets the current user. I will get into more detail on how this works in the next slides. And we basically use this injected current user to return the user details to the caller. And then we have the documents endpoint, which injects two things. As first, a database. So here we have to deal with the database. And the second thing it injects is a required permission, documents read, which basically means that you only can access this method when you have the read permission on documents. And we don't actually use the argument after that, but it will raise a denied exception if you don't have the correct permissions. And then the implementation is quite straightforward. We just query the documents from the database and return them as a JSON object. So what does this look like in practice if you want to test this? First, we have the getCurrentUser method. Let's see what that does. It injects the token, which is basically the Fast API session token you get, and the database. So those are injected by Fast API. Then we basically use the token to look up the user email. And if it doesn't succeed, we raise a credential exception. If it does succeed, we look up the user by email in the database, return it, and if it doesn't work, we raise a credential exception again. So let's have a look at the require permission method. This basically uses Fast API dependency injection to wrap a enforce permission method that looks the following. This method itself injects the authorization context by using getUserAuthentication context, and we basically use this authentication context to check if the user has the correct permissions for the correct resource and the action. If not, we raise a forbidden exception, otherwise we just return the authentication context. So what can we observe if we look at this code and we contrast it, for example, with the email? First of all, we can see that we require a database where the email doesn't require a database, and that the API is quite complex for a database. Basically, it's all of SQL, so that it's way more complex than just a send mail method. And therefore, it is quite tightly coupled to the app. It's not so easy to change your database out from under your app and go, say, to a NoSQL database. So in order to gain some confidence in our endpoint, what are the things we are interested in? Well, we would like to know that the authorization logic we have created in our app is actually triggered. And we also would like to test some scenarios where, for example, unauthenticated users can't access resources they shouldn't, and authorized users can, of course, should be able to access the appropriate resources. Mocking, in this case, wouldn't be such a great solution because you basically build up an entirely alternate reality because you have to have a lot of methods from the database interaction which you have to mock out, and you have to keep this up to date. Once your application changes, you have to update all your mocks again. So you're not really testing your app, you're really testing your mocks, which is not really something that will provide you with confidence. Therefore, this is a case where integration tests are better suited to gain some confidence. So what would this look like? Yeah, the first thing we have to do is set up the database. We use conf-test.py, which is basically the PyTest setup module. And we use test containers here. Who here has heard of test containers? Okay, a few people. It are basically Docker containers that you can use to spin up quickly infrastructure you need for your development processes and for your testing processes. So in this case, we use a test container for Postgres, and we spin up a Postgres test container here, and we yield it so it can be used in further dependency injections. Note that the scope on the fixture says session, which means that this will only run once per test run and not once per test. Every future invocation will basically just return the same Postgres test container instance. Then we move on to the next method, which is the create engine, which creates a SQL Alchemy database engine based on the connection URL to the Postgres test container. Then we create all our tables by calling create all, but you can also restore a database backup here, or create all your tables and then do an initialization script. Basically, whatever you need to do to get the database in a state where you can run your tests. And then we yield the engine. So after that, we create a DB session, which is just scoped normally again. So this will be run for each test, which is basically a SQL Alchemy session based on the database engine, which we yield. But here's something nice. After we have yielded it and we get the control back, we roll back the session. So this means that we roll back the transaction so that the database will be in a clean slate again, ready for the next test. If you have complex transaction management or you have the transactions already committed, you can also use something like Postgres templates to create a clean slate every time before you test. But this is faster, so when you don't need to do that, just a rollback on the session on the transaction is the easiest way to accomplish this goal. So, some more setup, but here we basically initialize some SQL Alchemy models. First, we initialize the group. We add it to the session and we flush it and return it. Now, the next thing is we create a user and we add it to that group, and basically we add it to the session again and return it again, just like in the previous time. So this is all the setup out of the way. With this done, we can use the test client. Client is something that Fast API provides for you, with which you can make requests on your endpoints for testing purposes. For example, we can check that unauthenticated users can't access their user/me endpoint. And we can do this by making a GET request without doing any authentication. And then we should get an authentication required for one status code back. If we want to check, for example, that admin users can access the documents, we first need to get a token, so an authentication token. This is basically a login. And we can use this token then when we do the GET request by putting it in the authorization header. And then we can assert that the response code is 200, so we get an OK. And the document, which we also created by dependency injection, is indeed the document that is returned by the JSON. So in this way, we can test the full endpoint working. When we look at authorization logic, and with authorization logic, I mean for example, the permissions from different sources. So users and group can have permissions if they combine correctly. We have wildcard permissions, for example, for admins who can do every action on every resource. We want to check that all those edge cases interact correctly with each other. This is the authorization logic I'm talking about. Would it be useful to test this with integration tests? And the answer is actually no, because first of all, database calls are slow, so you end up with slow tests. And if we take a random example and we say we have like 30 authorization logic tests and we have 20 endpoints and we want to test all the authorization logic on all the endpoints, okay, thanks. Then we end up with 600 tests, and that's a whole lot of tests. which are also all slow. So this is not a good solution. What is a solution? Writing testable code is a solution. And what do I mean by testable code? Is that you keep I/O and complex logic separated. Remember the sheet from a while ago I saw where I thought that testing is easy? This is the case because there is no side effects here. There is no I/O. This is a very simple example. Of course, it is exaggeratedly simple, but you can imagine you have some more complex arguments and return structures, but still, the point still stands. This is really easy to test. By keeping the logic separated from the I/O, you end up with pure functions for logic, which are independently understandable because you can just look at the input and the output. They're very reusable. So these are basically, it is a good pattern anyway, regardless of testing. You of course need to have some I/O in your app because otherwise your app won't be useful. But try to minimize the logic there. It's of course okay to have an if statement between some database calls. That's totally fine. But try to minimize the logic in your I/O functions. So once you do that, you can use unit tests for authorization logic because you don't have any database dependencies anymore. And they are simple, pure functions you can easily test with unit tests. And if you take that, the same example as last time, with 30 authorization logic tests and 20 endpoints, you say you do 3 integration tests for each endpoint, 1 for the unauthenticated case, 2 for some authenticated cases. And you add the 30 authorization logic tests, you only end up with only 90 tests, which is way less, and only 60 of those are slow because they use I/O. The rest is even fast. So what does this look like? Basically, we have a permission class, which is basically just a Python data class with a resource and an action and a matches method, which checks if the resource matches the requested resource or that the resource is a wildcard resource. In case it always matches, just the same for the action. And then returns an end of that. Then we have the principal, which can either be a group or a user. The most important thing is it has a list of permissions. And we have a has permissions method, which checks if any of the permissions in the list of permissions matches the requested resource and action. What would testing this look like? Well, this is way easier than before. We don't have to do any setup with any databases. We just can introduce some constants. We create some principles. We create some sample resources, some sample actions. And then we can, for example, assert that the documents reader group has the access to the things it should and hasn't had the access to the things it shouldn't. And for the admin case, which should be able to access anything, we can just loop over our sample actions and resources and assert that everything is accessible for the admins. So let's have a look at the performance. These are numbers on my laptop. It's not highly optimized, but it also is fairly simple. But the main takeaway, I think, is that auth endpoints, so integration tests that use a database, are 2 orders of magnitude slower than tests that don't use the database. So this is a strong case where it's preferable to have tests that don't use any I/O because they're just a lot faster. The dev container setup is even slower at 350 milliseconds, but that it only runs once per session, so it's not as bad as it seems. This isn't to say that you never should have any integration test, because I personally would prefer to have a 30-second longer deploy pipeline and catch the unaccessed, unauthorized access to an endpoint with critical data than have a 30 seconds faster deployment pipeline and don't catch that, but be aware of it. And when you are iterating on complex logic, having a test framework of just unit tests for that part is really nice for a quick feedback loop. So this is something other to keep in mind. Okay, a quick look at existing code bases. How do you tackle that? My advice would be to focus on the pain point first. Do this by tracking bugs and adding regression tests as soon as you find a bug. Meaning you first add a test to see if to reproduce the failure. This test should fail then you fix the bug, which should make the test pass. Keep this test around so you don't introduce the same mistake again accidentally in the future. Another thing to look out for is sections of code where that are hard to work on and feel people with dread if they have to work on that. Often the case, in this case, you have logic mixed with I/O. A solution for this can be to introduce first slow integration tests to add some confidence, and then slowly refactor to split out the I/O and the complex logic into two separate parts. You then can take the complex logic part and test it with unit test and move some of the tests from integration test to unit test, making it all much more efficient. Okay, in summary, the most important thing is write testable code. And a very useful pattern for this is to split I/O and side effects from complex logic. Then you will be able to test this complex logic with unit tests, which is fast and relatively straightforward for it being complex logic, of course. If you have simple integrations, for example, email, mocking can be a good solution. And for complex integrations, integration tests are the way forward. So, with that, are there any questions?